Hello students, in previous video we saw self-induction. Now in this video we have mutual induction. So first we'll see what is mutual induction. The way we have self-inductance in the phenomena of self-induction, here we have mutual inductance. So again there are two definitions. So we'll see two definitions of mutual induction which is denoted by M. And then we will have parameters affecting mutual inductance. So, a very small assignment. Let us start. Consider a coil connected with source of variable potential difference. So, here is a battery connected with a coil, and I consider that the voltage can be varied. So, when you allow current to pass through it, you will have magnetic field produced. And what if I have one more coil placed close to it? Suppose if I have another coil and it is not connected to battery but it is connected to a galvanometer. So if I label left one as coil 1 and the other one as coil 2, what will happen if I vary current passing through the first one? Suppose current here is I1. So when I change value of I1, the flux linked with the second coil, that is phi 2, will change, isn't it? So I can say that phi 2 is directly proportional to I1. Okay. What is phi 2? Phi 2 is total flux linked with coil 2 or inductor 2. What is I1? Current passing through coil 1. So we have total flux of second coil which is directly proportional to current passing through first one, and then if you remove proportionality you have a constant of proportionality M. This is called mutual inductance. As you are talking about mutual inductance of second coil due to first one, it is denoted by M21. Similarly, if you are allowing current to pass through second coil and if you are looking at flux linked with the first one, then the equation can be phi 1 is equal to M12 I2, because you are passing current through second coil and you are talking about flux linked with the first one. So phi 1 is equal to M12 I2. So what is M21? M21 is mutual inductance of coil 2 due to current passing through 1, whereas M12 is mutual inductance of 1, coil 1 due to current passing through coil 2. So that is mutual inductance, and this is very similar to the one we have in self-induction, where we don't need suffix. In case of self-induction, we simply have phi proportional to I, and then we say that phi is equal to Li. Because you have only one coil, so flux and current both are of the same coil. But here we have two coils, and so we need to use suffix. And from this, I can define M21 as phi 2 by I1, or else I can say that M12 is phi 1 by I2. So how do I define mutual inductance then? In terms of flux, I can say that mutual inductance of coil 1 due to 2 is flux linked with the first coil due to current passing through second coil. I am repeating. Mutual inductance of coil 1 due to current passing through coil 2 is flux linked with the first coil per unit current passing through second coil. Okay. And what should be the unit? According to this definition, unit should be Weber per ampere. just like unit of self-inductance. And then you have one more possibility here. If you take, suppose phi 1 is equal to M12 I2, and what if I take differentiation on both sides? Then we have, sorry, minus epsilon 1. Apply Faraday's law. We know that epsilon is equal to minus d phi by dt. Okay, rate of change of flux is equal to induced EMF, and negative sign is consequence of Lenz's law. So here I can say that minus epsilon 1 is equal to M12 di2 by dt, or else epsilon 1 is minus M12 di2 by dt. What if you take phi 2? Phi 2 is M21I1. So d phi 2 by dt is M21 di1 by dt, and then minus epsilon 2 is equal to M21 di1 by dt, and hence epsilon 2 is minus M21 di1 by dt. Make M subject of formula here. So what you will have? So M12 can be written as minus epsilon 1 by di2 by dt, or else you can say M21 is minus epsilon 2 di1 by dt. So from this we can have one definition of mutual inductance, which says that mutual inductance of coil 1 due to 2 is epsilon 1 per unit di2 by d1. What is epsilon 1? Induced EMF in first coil per unit rate of change in current in second coil. What is di2 by dt? Rate of change in current in coil 2. Let me define once again. M21. What is M21? Mutual inductance of 2 due to 1 is induced EMF in second coil per unit rate of change in current in coil 1. So from this we have another unit of mutual inductance, that is volt second per ampere, or else you may say combining these two and applying Ohm's law, we can say it is ohm second. But popularly mutual inductance is also measured in terms of Henry. So just like self-inductance, we have 4 units here, which are the 4. 2 are shown here, and one previously mentioned, which was previously mentioned unit, Weber per ampere. Okay, so that is what we need to know about mutual induction for now. Now if I compare self-induction and mutual induction, how many points of comparisons we have? So self-induction and mutual induction. What happens in case of self-induction? In case of self-induction, you have one coil, and when you allow current to pass through that coil, you are having flux linked with it, and when you vary the voltage potential difference linked with the coil, the flux changes, and hence you have induced EMF. Whereas in case of mutual induction, you have two coils. Just like previous case, you have one connected with variable battery and another coil which is not connected with battery, but it is connected to galvanometer. So in case of mutual induction, you have two coils, and if you allow current to pass through first coil, you are producing magnetic field, and that magnetic field or magnetic flux is linked with second coil. So if you change I1, phi 2 will change. Okay, so in case of mutual induction, the condition is phi is proportional to I. Here also phi is proportional to I, but you will have to mention which phi and which I. So phi of 2 is proportional to I1, or else you can say phi of 1 is proportional to I of 2. Okay, depending on the condition. In case of self-induction, phi is equal to Li. The proportionality constant is L, which is self-inductance. Whereas in case of mutual induction, we have phi 2 is equal to M21 I1, or phi 1 is equal to M12 I2. Okay. In this case, we have one more. L is written as phi by I, or else epsilon by di by dt. Induced EMF per unit rate of change in current. Here also M21, if you are talking about, it is phi 2 by I1, or else you can write it as minus epsilon 2 upon di1 by dt. Okay, so equations are very similar except the suffix, and then you have 4 units, which are the 4: Weber per ampere, volt second per ampere, ohm per uh, sorry, ohm second, but popularly Henry is preferred. Similarly, in case of mutual inductance also, the same 4 units: Weber per ampere, volt second per ampere, or else ohm second, but mostly Henry is used. The phenomena of self-inductance induction depends on number of turns of the coil. This also depends on number of turns of both the coils, size and shape of the coil. This also depends on size and shape of coils, both the coils. Sorry. Self-induction depends on medium of core. What you have inside the inductor, what you have inside the coil. Here also, medium is important. But then we have one difference. The distance between two coils is important here, which is not the case of self-induction. Distance between two coils. It is a parameter which affects M, and relative orientation of the coils. What does it mean? It means that suppose one coil is placed like this and another coil is placed like this. You will have some induction taking place, but what if you have two coils placed like this? Then you have more flux linked with second coil due to first one. So in this case, the flux linked will be less. So how the two coils are oriented with respect to each other is also important in case of mutual induction. So those are the parameters affecting the phenomena of mutual induction and the parameter mutual inductance. And that is all for now. Thank you.